Hello. In this example, we're going to look at the end behavior of even and odd degree polynomial functions. Now, first, notice that this is not saying that the function itself is even or odd, because there can still be a combination of even and odd degrees in the function itself. But remember that the degree of a polynomial is just the highest degree that exists. Now, when we're talking about this, let's look at some examples. I'm just going to look at the parent functions, basically. Y equals x is going to look something like this. Y equals x cubed looks something like this. Now, obviously not exactly like this, but I'm not good at drawing. X to the fifth can look something like this. X to the seventh, x to the ninth, and so on and so forth. Now, notice, here, let me make that look a little bit better here. Notice that all of these are starting at the bottom left and ending at the top right. Also notice that these are all odd degree polynomial functions. Now let me change this up just a little bit. Instead of using positive leading coefficients, what if I use negative leading coefficients? Y equals negative x will look something like this. Y equals negative x cubed looks something like that. Negative x to the fifth will look more like this. Negative x to the seventh, and so on and so forth. Notice that they're all starting at the top left and ending at the bottom right. Notice that they're on opposite sides here. The same thing up here. So, for odd degree polynomial functions, the function either begins at the top left and ends at the bottom right, or it starts at the bottom left and ends at the top right. Let me make this consistent with these real quick. So it can start at the bottom left, end at the top right, or start at the top towards the left and end at the bottom towards the right. Now, you can think of these as up or down if you want. So as you go to the left, it's going down. As you go to the right, it's going up. Or as you go to the left, it's going up. And as you go to the right, it's going down. Now, let's look at the even degree polynomial functions. Notice y equals x squared would look something like this. X to the fourth would look a bit like that. X to the sixth, and so on and so forth. Now, if I looked at the opposites, in other words, the leading coefficients being negative, it can look something like this for this negative x squared, negative x to the fourth, negative x to the sixth, and so on and so forth. Notice that the functions are ending and beginning on the same sides. Okay, and these are all even degree polynomial functions. So, as you go to the left, it will go up, and because it's even, it's on the same side, so it's going to go to the up on the right-hand side. Or, as you go down to the left, it will go down to the right as well. Notice that this is a positive leading coefficient. This is a negative leading coefficient. And over here again, this is the positive leading coefficient. And here is the negative leading coefficient. Alrighty, now these are very similar to the behavior at the zero. Now, notice whenever I say behavior at the zero, I'm talking about x-intercepts, basically. So if you look at behaviors at zero, it all depends on the multiplicity. So if the multiplicity is odd, here's what it looks like. If it starts on the bottom of the graph, it's going to cross to the other side like this. Or if it starts at the top, it's going to end on the bottom like that. Now, if the multiplicity is even, it's going to start and end on the same side. But notice that it still has to touch the x-axis, and it's only going to touch in one place. And so basically what happens here is it goes down, touches, and then bounces back the other way, or in other words, the way it came from. The same thing happens down here. If it goes up and touches, and then bounces back down the other way. So odd multiplicity crosses, even multiplicity bounces. Okay. Odd opposite if you want to think of it that way, and then even bounces or same side if you want to think of it that way as well. Now another thing, right here I've shown multiplicities that are multiplicity of 1 because they look like lines as they're crossing. However, it is possible to have a higher degree. So if I look at, say, multiplicity of 3, it could look something like this. It would look cubic as it's crossing. Or if it was multiplicity of 5, it would look more like a 5th degree polynomial, and so on and so forth. So it really does depend on the multiplicity. Alrighty, well, I believe that's it. Have fun. I'll see you next time.